All right, welcome back. We are COMP123, that's Programming 2 at Centennial in the summer 2020 semester, and we're week 5, part 2 of our broadcast, and we're talking about more polymorphism stuff, right? So last day what we talked about was a little bit of how classes, I can think about classes as blueprints. We also talked about, what inheritance is, again, very briefly. We kind of went through that. And then we got into polymorphism, and it took us to around here where we talked about the toString and overriding and everything else. And I'm just going to take us down to where we were, right? Because I'm going to get back to that that page, not get type. I think it was something down here. There we go. This one, object. And maybe even further back. I'm just going to try and make sure that we're at the same point for everybody, because I don't want you guys here. I think this is where we were. Base class. How we talked about the base class and how we can use the base class to access the parent class. We haven't talked about this yet, but this is where we are. I'm working with this project, and I have many classes here. I'm not using one file for every class. My expectation is, as you guys are programming in with Visual Studio 2019 and C#, that you're going to have multiple files that you're going to hand in for your next assignment. I haven't given you your next assignment yet. I'm waiting for you guys to finish the assignment that's been given to you by Professor Narendra. So, but the next one is going to ask you to do different things than what you've already done. And notice what we did, just as a review. We created a couple of classes. The first one was this vector2d class, which is like a struct, and the vector2d class just gives us x and y coordinates. We also have a public constructor that is that takes in two variables, x and y, but we also give default values to x and y, and you should know about this. Default values means that if I don't enter anything at all, then they will assign values for x and y. And that's how it works. So that's something that, and I think I'm getting somebody trying to come in our waiting room. Let's take a look here. So this is where I gotta kind of go crazy here with the waiting room stuff. Yeah. So when it comes down to it, when you have this this stuff here, when you have like a class like this is a very small class, and you can add additional things to this class. For example, in a vector2d, sometimes what we want is some methods that are static methods. So can anyone tell me what's the difference between a static method and a non-static method? What are statics anyway? Can anyone tell me that? Maybe in chat. Static versus non-static. What's a static method? Static values remain the same. Okay. Well, what is a static method? How can static belong to the class, not belong to the object? Okay, I like that. That's very good. That's a good response. What does that mean? Statics belong to the class. Static is a shared value, potentially. Yeah. What else? So I'm talking about static methods here, not static properties. If static values change, reflects all of them. Yeah. If I wanted to do that. So what about static methods? What we use static methods for? Think about this. It'll change static fields only. Static only can access static. Okay, let's get to this. So let's suppose that I want to return something, right? I want to have a vector2d, and in my vector2d, I want to return specific values. I want to have some helper functions to do this. So if we're going to go down in here, we're going to say public static methods. So that's the difference between just regular public methods. So public methods will be just for you have to instantiate. Static methods, there's no need to instantiate the class. There's no need to instantiate objects at all with static methods. It's part of the class. So for example, I could have a static method So here's public static, and this is in the vector2d class, okay? Public static, and let's say, for example, I want to return something called up. Okay, so there we go. Or let's start with 0. So a public static method that returns something. It's going to return something. It's going to actually return itself. So vector2d is what it's going to return, and the method's going to be called 0. Okay. Let me explain this for a second while I let another person into class who's late. So what does 0 do? So 0, I want to return a vector2d that's been initialized to 0. All right, that's kind of what it is. So I can say that I want to return a new vector2d object, and the values are going to be just 0, 0. Okay, that's what this can do. Okay, so I'm going to make a couple more of these. So this is one example. So notice what this does. So public static. Static means I don't have to instantiate to use the method. I want you to think of it this way. It's part of the class. So here's another one. Public static. I want to make another thing that returns a vector2d as an example, and the method's called up. And think about what up means from a vector perspective. X goes across and Y goes up and down. So up would then be a positive 1 up, right? So I can say that up returns a vector2d that does 0 on the x-axis, right? But it actually gives me positive 1 on the y-axis, right? So that's up, right? Does that make sense? So 0, 0, 0, up, and let's do a couple other ones just to give you a sense of how we can use this. So we can do one that's called down, which would be a negative, right? So up 1, down is down. Okay, this is again assuming that my coordinate system is similar to the Cartesian coordinate system in math. Okay, if my coordinate system was a 2D coordinate system where it started at the top left corner, 0, 0, then this would be reversed. These two would be reversed. But typically what I'm assuming here is that anything below the origin is negative. Anything above the origin is positive in this particular case. Okay, let's do more. So we'll kind of do one that is to the right, and now this would be 0. You guys should be able to guess this. This would be a 1, and we'll do one more. Copy this one now, and we'll do it to the left. We'll call this left. Okay, and this will be negative, right? So so this way I don't have to actually create these vectors. I can just say I want a vector, I want the object to move to the left. You know, I can assign, I can, you know, kind of take this and use this to make it move to the left. All right, so this is kind of the way that I can make this work, right? So I can save this class, and then inside the program.cs, right, as an example, and let's get rid of some of this stuff. So I'm going to get rid of some of this stuff. So there's a boss, a red enemy, a green enemy, but I want to just move the player, so I'm just going to get rid of this stuff for now. I've already saved this as a commit up on GitHub, so I can always get back to this if I want. So here's my player. I want to raise my shields. My transform position starts off at 100, 100, and I want to move this player to the right. So what I want to do is I want to say that, and this is interesting, I want to add a vector. I want to add to the position some kind of vector. Can I do this by default? So let's think about this for a second. First of all, what does it mean? So if I say player.transform.position, right, is equal to, instead of making it a new vector2d, remember that I can use my, look what's happening here. It's already suggesting some stuff to me. It's saying, hey, I can just assign something. Like, for example, I can assign write. So I can, instead of using the new keyword, because I'm using the static method that belongs to the class, I don't have to instantiate anything, because the class itself will instantiate the object for me. It'll instantiate an anonymous object and return a reference to it. That's what it does. So what I can do here is I can just say vector2d dot, And then I have some objects, some things I can do with vector 2D. All right, so I can go down, left, right, up, and 0. Let's go right. So you can see that this works, right? Because position is a vector 2D, and I'm assigning another vector to it because vector 2D itself, the class, has a static method, things that I don't have to instantiate. When I call the static method right, it creates a vector 2D for me and returns a reference to it and stores it inside the position vector. That's what it does. Okay, so I don't have to instantiate by using new. I can just use this, right? Because the way I've made a static method. All right. Now, wouldn't it be nice if I can add two vectors together? Wouldn't that be nice? Well, the one way I could do it is I can make an add method, right? I could make an add method. But wouldn't it be better if I did, if I kind of added them together using operator overloading? Did you guys cover operator overloading? Please put a check mark or an X in your participant. If you understand what operator overloading is, put a check mark. If you don't, put an X. I'm seeing some X's. I see one check mark. All right, so lots of X's. All right, and one check mark. Okay, so what is operator overloading? Well, what I wanted to do, thank you for that, guys. I appreciate the feedback. What I wanted to do is this. I'm just going to put this in some comments. So I want to do something like this. I want to do player.transform.position, right, is plus equal. I want to do plus equal to vector 2D right. That's what I want to do, right? And how can I do this? Remember, this is another part of polymorphism. I want to be able to add something to an existing vector, but the vectors that I made right now, the vector class, has no idea how to add a vector to itself. I can't do that. So if I was to uncomment this, I'm going to get an error, right? It's going to say, if I hover over, it's going to say operator plus equals cannot be applied to operands of type vector 2D and vector 2D, right? Cannot apply a plus equals operand, okay? So I have to create that. That's what I have to do. I have to make it work, right? Where I have to make this happen, right? So if you look up, so C# has some great resources online, okay? So if I say operator overloading, right, and C#, okay? So let's just look at this. And you can do this anytime to do this. And I'm going to ask you to do operator overloading at some point in the future, right? It doesn't matter where you go, whether it's the docs at Microsoft or C# operator overloading tutorials point, doesn't matter. But you can certainly go somewhere like this and it'll explain it nicely for you. Okay, so one thing we need to use, if you notice, first of all, here we have public statics. All right, it shows us public statics as one way of doing it. And here is we made this a struct in this particular case, okay? And that's what they're showing us here on this up on the Microsoft site, okay? But notice what it's saying. We use the keyword static, the name of the class. In this case, it was called fraction, right? The keyword operator, which basically says to the compiler, hey, we're doing something with this operator. Okay, that's what we're doing. And then what operator you're modifying, so the plus in this particular case, or the minus, or the plus, or whatever you have here, okay? And then, now this is a lambda expression, but don't worry about this, some kind of return that's going to return a new class based on what you're getting. And we're going to do this in a second, okay? And it gives you some it talks about different operators that you can overload. You can overload unary operators, binary operators. You can overload all these kinds of operators, compound assignment operators, it says cannot be explicitly overloaded. However, when you overload a binary operator, the corresponding compound assignment operator is also overloaded. So plus equal is evaluated using the plus, which can be overloaded. Okay, so that's kind of telling you what can be done. So that's the keys. The key is static, right? Operator, and then some kind of returning function. Okay, so pretty simple for us to do this. And this is going to make our vector more usable, right? So we're going to talk about this in a second. So that's something that we can do. So let's look at the other one. So that's one resource. We can also look at C# overloading tutorials point and see what this says. So again, we have our static member, operator, the sign that we're overloading, and then some kind of function that returns a new object. All right, the new object that we're trying to overload. Okay, so pretty simple stuff. This is a pretty simple methodology. Okay, so let's try this out for ourselves. So again, what I want to do, I can't do this here yet, right? Plus equals to vector 2D, right? And what I want to do is fix up my vector 2D object. So go back to my vector 2D class, and again, so we have static methods, right? And typically what I do when I do any kind of overloading, I mean, you can definitely put it in here if you want, but I'd like to put it close to or near the constructor. So I like to kind of say something like public operator overloads. Okay, so that's what I kind of do. This is my way of doing it. You can put as long as you comment it, it doesn't matter where you put this in the class. All right, but I like to put it somewhere that is before my vector 2D. So remember what the thing is: public, static. Those two things you need, and then you need the thing that you're returning. I'm returning a new vector 2D. That's what I'm doing, and then I'm going to use the keyword operator. Right, here's my operator. The operator I'm overloading, plus, right, as an example, and then some kind of methodology for how I'm going to do that, what I'm going to get. So I'm going to get, in order for me to do, I'm going to add two vector 2Ds, I need to add two vector 2Ds together. So on the left side, this is what I'm going to get on the left side, vector 2D, and I'm going to call this thing, we're going to call this the left side, right? And again, let's go back to that example online to show you. So I'm just following a pattern here. So notice that there is box B and box C, and what's going to happen is when I take in this example, I'm going to make a new box, and then it's adding up the lengths. That's what this is doing when you add two boxes together, and it's returning a new box. So it's kind of declaring it here, and this is the operator overload example, where if you go through here, it's public static, you got operator to add two box objects together, and then the tester class, you're going to have box 1, 2, 3, and notice what happens is, what we want to do is we want to add up kind of box 1 and box 2 by using the plus symbol somewhere. Okay, so somewhere down in here we want to use the plus symbol to add these two things together. For example, something that looks like this, box 1 plus box 2. And you get the third box. That's what happens. Okay, so similar for what we want to do, we want to use the left side and the right side. So usually you kind of call it left-hand side. So I might do something like left-hand side, right? And then the right-hand side when I'm adding two vectors together. Now, in there, you have to define a return type. Okay, so you can't just say, hey, here's what I want to do. I need to return something. I need to return a new vector. So obviously the best thing to do is we got to think about what a vector's, how we do this kind of stuff, right? Remember when I add up two vectors, what I'm doing, I'm actually adding the x's and the y's together, right? That's what I'm doing. So it's like, let's put this like this. For example, I want to float. So we'll call this the x's, right? And I can do something like this. I can say, well, x is equal to left-hand side x plus the right-hand side x, right? Add those two things together. That's the x's. And then I want to do the y's when I add them together. So I can say that that is the left-hand side y plus the right-hand side y, right? And add those two things together. So those two things give me the x's and the y's. And then what I can return, if I want to, is a new vector 2D object that uses the x's and the y's is something that I'm making. And that, my friends, is an overloaded plus operator. Okay? So that's how this works. And if I want to do the same thing with a minus, let's just do the other ones. So minus. So I want to take the minus operator this time. So I want to take the first one and subtract it from the second one, or subtract the second one from the first one. So I'm going to say left-hand side, it doesn't matter how we do it, minus right-hand side. We just put the minus in there instead of the plus. And then we're going to have a new vector2 object that is minus. Okay, so that's going to cover the minus. Let's do the other ones. So typically what we want to do is that when I want to multiply two vectors together, we don't usually do multiplication this way. Typically what I want to do instead is I want to multiply a vector by a scalar. And a scalar is just a single float or something like that. So I'm going to make my vector, when you multiply it, you can't multiply it by another vector. Well, actually, let's do it that way. And then we'll make a scale function. So, so then I can do the same thing with the multiplication sign. So when I'm using multiplier, left-hand side, right-hand side, I'm going to multiply these together. Okay, not really what we normally do. And let's do one more, right, where we divide. Now this is dangerous because I can have a divide by zero error here, right? So divide, if I do the proper divide symbol, there we go. So this is the divide symbol, but what happens is if we take the left-hand side and the right-hand side happens to be 0, so if I do this, right, the right-hand side has a potential to be 0, right, which means I can throw a division by 0 error if I'm not careful, right? So we got to be really careful about this, and but let's suppose that our code's not going to do that. So we've got like 4 operator overloads right now, these ones. And now let's see, once I've got this, how does my program look? It's fine. Take a look at that. It's fine, right? So that's definitely one way of doing it, where I can say that I add a, so what plus equals is the shortcut operator. It really means take the player transform position and then add a vector 2D to the right to it. And then what I can do is, let's just show the console again. All right, so I'm doing a console toString for my player, and I do it again. I want to see that it adds 1, and it should add 1 to 100. So it'll start off at 100 and 100. That's the coordinate. And then it's going to go to 101 and 100. Okay, that's what this is going to do. So let's see if that works. Or if I'm going to get an error. Let's see what happens. Cool. So then it started off at 100, 100, x and y, and I'm adding 1x to it, and it's going to 101, 100. Perfect, right? That's how it should work. And I can do that by creating our own custom plus operator to move us to the right. Okay, so that's cool. Okay, what about if I want to have multiple plus operators? Is that possible? So what that means is I have one signature. So here's a signature. I can add a vector to a vector. I can multiply a vector by a vector. I can do this. But what if I want to multiply a vector by a scalar? Is that allowed? Can I do something like a vector and then the right-hand side has to be a float? Is that possible? So I can say, hey, you know what? I want to take, there's 2 possibilities for multiplication. One possibility is I want it to multiply by another vector. The other possibility is I want to multiply it by a float. I want to take the almost like a scale. This is what this is. This is kind of a scaling function, right? Where what I'm doing here when I multiply it by a single number is I'm uniformly scaling the vector by the same amount. Okay, so taking both left-hand side x and y and multiplying it by the right-hand side number, whatever that is. All right, so instead of using a thing, and then I'm just making a new vector based on that. So that's another option. So you can actually have 2 overloads with the same operator, right? But different signatures, just like any other overloaded function. Okay, so that's what it does. So I can have 2 different signatures here. One that takes vector, vector, the other one that takes vector float. Okay. Again, I'm not seeing a lot of usability for this one. Typically, division is not done like this, but if you want to, we can. We can also do dividing by a number, as an example. So I want to, let's say, scale. This scales up, right? If I multiply, it scales up. And multiplication also can be used to scale down if I put like 0.5 in there or something like that, right? So, so that's pretty cool. So now why would I do this? Well, it allows me to do something that looks like this. So let's suppose I want to move it to the right, but I want to then multiply it by some kind of speed. So let's say we define up here, right, a player speed. So I say, so we'll call this float, player speed, right? And let's say the player speed is going to be equal to 20. And let's say this is like 20 units on the map somewhere, whatever that is. And then I want to take my vector to right and multiply it by 20. Like for something, for example, something like that looks like this. Multiply it by player speed. And now that becomes possible, right? Before, if I try to do this, what this is actually doing is it's taking the existing vector, multiplying it by player speed, right, first, and then adding it into the position. So, for example, I said that 20 is the player speed. Multiplying it by 1 on the x-axis should give us 120, in terms of our new position, whatever that new position is going to be. All right, so let's try and test that out. And you can see that is exactly what we get. We get 100. We add 1 to it, multiplied by 20, right? So that's to the right, 20 units. That's what this does. And if I was to change this, and if I said this, let's move this to the left instead, as an example, then you're going to see that it's going to go to 80, just like we predicted. 100 minus 20, right? So that's pretty cool, right? And we can do that same thing with up. If we change this to up instead of that, we can see that we're going to get our vector moving up on the y-axis, but not anything on the x-axis. That's pretty cool. That's why we make those little functions. So what did we cover just now? We just covered how to do static methods with a function, and we also did how to make use of operator overloading. All right, so we're going to do operator overloading in an assignment in the future. I'm just letting you know that you need to know how to do operator overloading. And the reason why is because when we make our custom classes, sometimes, especially when it comes to things like math, we want to be able to add, subtract, multiply, and so on. Right? So that's another thing we can do. Right? And also, static methods are really important for us to use for utility methods. So let's say, for example, I don't want to instantiate something, but I want to calculate something. For example, I want a method that gives me the dot product, right, of two vectors. So again, if you don't know what dot product is, don't worry about it. We can look it up. So dot product of two vectors, how to do that, right? And if we were to look up dot product, it basically shows us what to do. This is just math, so again, don't worry about it. But basically what you're doing is you're saying that when you do A dot B, right, how does that work, right? So so it gives us some examples here. In math, this is not a great one. I want to give you a very simple way of doing it. But basically, it's you take the components of the vectors, you multiply them together, and then you add them up. And what the dot product does is it returns to you a scalar, right? So, for example, if I have a three-dimensional vector here, 1, 3, minus 5, and 4, minus 2, minus 1 in this Wikipedia page, right? And we take the dot product of these two things. We take the first components, so x's, and multiply them together, so 1 and then times 4. And then the second component, 3, and then times minus 2. Right? And then the third component, minus 5 and minus 1, multiply all that together, and then add up the results, and what we get is a scalar at the end, just a regular number, right? So that's interesting. So that's a good, we use dot product for lots of stuff in in game development. For example, we use it to calculate the angles between two vectors and a bunch of other stuff. All right. So dot product is really interesting. So if we're going to make a dot product method, right, for our vector class, let's do that now. We make it as static method. First of all, we added some operator overloading, and this would be a great time to put this up on GitHub. Notice I've modified my program.cs file, and I've also modified my vector2d class. Let's do that. So we'll say added operator overloads for vector2d. Okay, that's what we did here. Commit all. And then home, sync, and push. So now you should have all that up on GitHub for yourselves. Okay, so operator overloads. Kind of very simple to do. Very cool. It's going to almost die there. It's done. And now what we want to do is we want to add a new thing. I want to add a new thing to vector2d, right? And the new thing, I'm going to make this as a static method again. And notice I've got some interesting utility methods, up, down, right, left, and so on. And I want to add a new one called dot. So public static. It's going to return a float. That's what it's going to do, potentially, right? Not a vector2d in this case. And it's going to be called dot, right? And we're going to take two vector2ds. So we say vector2d. And again, what we want to say is left-hand side. And we want a vector2d on the right-hand side, right? And what it returns, we return a float from those things. So we say that we want to take the left-hand side, right, dot x, and we're going to multiply by the right-hand side dot x, multiply by the right-hand side dot x, right? And we want to add it to the left-hand side, left-hand side dot y, multiplied by the right-hand side dot y. Okay, so that I just did it in one line here instead of making extra variables. This right here is the dot product of these two vectors. That's what it returns, and it is a scalar product. Okay, so that's what this does. So we can test this. So if I go back to my program and I say I want to get the dot product of two vectors, I can just do that. I can say that we'll call this vector2d. This is for testing. So we'll say vector1, right? And let's say that's equal to a new vector2d. And let's say the vector is 3.0f and 5.0f, right? And we'll make another one where we say a vector2, like the second vector, vector number 2, is, let's say we'll make this something that's 5, and 5 will be something like 10, right? Okay, and what we want is the dot product, so a float dot, and that's equal to we can use now the vector2d class, right, as a utility class, dot dot, and now we need two vectors we're going to pass in, vector1 and vector2. And what this will do is it'll return a floating point number, that's what it does, and then we'll print it out. So again, console.writeline, right? And console.writeline, we're going to output dot, whatever that is. And if you want to, we can just simply say that that is the dot that we're going to output. Let's say that and do it in a method. So we're going to say dot, and we're going to say the dot product is whatever it is, right? And then let's run it and see what we get. So dot product of 65. So that's interesting. So let's test that. So how does that, to make sure how that works, we get, again, x is multiplied by together. 3 times 5 is 15, right? And then 5 times 10 is 50. 15 plus 50 is 65. So we get the right answer. Okay, so that's how it works. And we didn't do anything. We didn't instantiate here. We didn't instantiate a new vector. We just used the vector2 class as a utility vehicle. That's what we did. We said, hey, I want to, you know, it's a vector. I'm taking in two vectors, right? Well, I want to use the vector2D class to do that for us. Okay, so that's static methods. Static methods, and you should have learned something about static methods before. But what I want you to take away from this one is that static methods do not need, you don't need to instantiate a new object to use a static method. You can just use the class itself. I can say, hey class, let me use this method of yours without instantiation, okay? And this presents other options for us. If I don't have to instantiate an object to use the class's method, this is great, right? We can use something that makes sense. Vector2D, I'm using some kind of mathematical formula to do that. Dot, as an example, would be a math type formula. There's other math formulas we can use. For example, I can find the angle between, you know, as an example, between two vectors. Sometimes that's very, very useful. And there's a bunch of other things that we can use. You know, for example, the magnitude. That's another one that's really popular. Let's do that one and we'll stop. Okay, so I want to find the distance between two vectors. Okay. So there's if we're going to use Euclidean distance. Okay, so we're going to say public static. I want to use the distance. Distance is going to be a floating point number in units, so float. And we're going to call this distance. And we're going to take two vectors, vector 2D left hand side and vector 2D right hand side. So I want to find the distance in units between the two vectors. All right. So if you remember how this works, right, we wanted to use the square root. Now in games, I have to have a disclaimer here. In games, we don't want to do this because once we start thinking about the distance, we have to use square root. Square root calculation many times per second is really computationally expensive. And what we'd use instead is something like squared distance. But for now, we're going to use just this distance, assuming that somehow our game is fast enough that I can take it. And so how does this work? I want to return the square root, right? This is the distance formula. So math.square root. And you're going to take the square root of the exponent, right? So the squares of each of the components. So I want to take left-hand side dot, sorry, we'll start with right side. Right-hand side dot x minus the left-hand side dot x, right? So I want to take that. And I want to add it, I'm going to have to square it in a second. And then I want to add that to the right-hand side dot y minus the left-hand side dot y, right? I want to add this together. Sorry, someone's just joined. All right, so I want to do this calculation. By the way, it says that when I do that, it returns a double, which means we're going to have to convert it to a float, which means we're going to truncate the result a little bit. Okay, so we're going to convert it in a second because we need to do this because this math.square root stuff, it makes a double. If you notice, if you hover over square root, it tells you it returns a double, right? And our function returns a float. Okay, so we're going to do this in a second. But this isn't complete, right? We want to use math.power here. Math.power, where we take the first argument and we square it. Okay, that's math.power. And we want to do the same thing with the second one. So math.power, right? Where we take this to the 2. We could also, instead of doing 2 calculations in one, I could break this out into right-hand side dot x and left-hand side dot x up here, and then so in a variable to make it better performance. Okay, so we can say so a float. We can call this difference the x, the difference in x's, right? We could definitely do that. Guys, you are really arriving late. This is an hour late. In the future, I'm going to limit the class so people can only arrive within half an hour. Just letting you know. All right, so difference in x's. And if you look at the difference in x's, I can just do one of these. So I can do the right-hand side x. There's another way of doing this calculation, right? And float difference in y's. That's equal to the right-hand side dot y minus the left-hand side dot y. Right, so that's the one way I can do that. And then what I can do is instead of squaring it, or like this, I can just multiply that by itself. I can say diff in x's times diff in x's. So I don't have to do that squaring, because squaring, like using math functions twice, that's even worse, right? In terms of performance, right? In general, I'm saying. And I can say diff in y's multiplied by diff in y's. That gives you the same result. Still, I need to use math square root. I have no choice in this particular case. But one thing we need to do is convert this into a float. So, so again, if I was going to convert, right, I can start off with float dot, and then you can see that there is a parse function, float dot parse, and that will convert a string to a float. So notice it says I get a float. The other way to do it is to say that I want to convert. If I did this, you know, float dot, and you notice it says that there's that. By the way, float is an object type as well. So you can see that isnan, try parse, type of, right, and parse. So if float dot parse, right, and again, the options are, these are all the different kinds of ways. It says converts the string representation of a number to a single percentage. So this is not what we want. We just want to cast it, right? So typically what we do is we do one of these, right, which casts a number to a float, right? That's a way of casting, right? Another way we can try is I want to cast this thing as a float, right? And remember what we can do here. Can I do something like this, right? Where I want to cast this thing as a float instead of a vector, of a float. So can I do it this way? Can I do, hey, I want to cast this thing? No. But you can do, hey, I want to cast this thing. And this is the old school way of doing it. I would love to be able to do this. I want to change this into a float, right? I want to say, hey, this is a float, right? And that's how we do it in C++. We do it this way, float, you know, thing. But the old school way of doing it is this way, all right? And if you look at number conversions, again, if you go up online and if you go to convert double to float and then C#, it'll tell you exactly this. So how do I cast? So it says here, another one is convert to single. That's another way of doing it. Convert to single, right? So to single, right, as an example, this is the .NET reference source. So to single, let's see if that works. So if I, instead of doing this, I said convert, I use the convert key class, dot, and then these are all the things that can convert to. So to single, it returns a float. It tells you right there, to single. U short, unsigned short. U int, unsigned int. U long, unsigned long integer, and so on. And there's many, many other things you can convert to, right? So I want to convert to single because a float is considered a single, not a double. So to single. So, right? And then I can pass in a double value. And by the way, I recommend using this methodology as opposed to the old school conversion. This is a little bit more explicit. From a user perspective, it tells us what we're doing. We're converting it to a single. And what this is also doing for us guys is we're chopping off you know, precision digits when we do this kind of work. Okay, so now this is how we do the distance function. All right, so let's test the distance function to make sure this is good. So yeah, float value is somewhat we can do, but we can also, this is the better way to go. All right, so let us, sorry, that's not what I want. I want to go here. And if I was to do this instead, so I have the dot product. Let's get the distance between these two vectors, right? So by the way, let's just, for completeness, let's do console log here, console Writeline. I just like to call it log. And I want to say, you know, value of vector 1 is, and I want to add in a value for it. Remember, we can do a toString value. So plus, we can say vector1 dot toString. We can do that, right? And we can do the same thing just to make sure that we have the same thing. We can say the value of vector 2 is vector2 toString. So we know what the original values are. We can change these and try this out later. And then we have vector 1 and vector 2 for the dot product. And now we're going to do the same thing. We're going to say float distance, also known as magnitude in some ways, between two vectors. Vector 2d dot distance, and we need two vectors for this, vector 1 and vector 2. Okay, so that gives me the distance, and then I can do a console Writeline. By the way, if I start typing const C, right, and if I want to, there are some shortcuts for console Writeline as well, because we do it so often. So if I start typing console, right, a lot of times what you can get is the shortcut for this. Now, unfortunately, it doesn't give you this. I think is it CW? No, that's currency wrapper. Let's try, is it CCW? I can't remember. Anyways, there is a shortcut for console Writeline. I'll figure it out and I'll post it. So console Writeline, and we want to do again the distance between vector 1 and CW, press tab. I thought so. And vector 2 and vector 2 is, and then $ brackets, and we want to put in the, sorry, $ should go out here, is distance. Okay, so that's the distance between in units, and whatever units that is. So if I write this and then I run it, then we should see that as a distance formula, right? So we can see the distance is 5.385165 units, whatever that is, right? And that's the distance between vector 1 and vector 2. Okay, so we can try this out to see if it's a little different. Distance is like the Pythagorean distance or the Euclidean distance, right? So we can also look at some known distances. For example, if I know I have a line, right, as an example. So if you notice what 3, 5 is, vector 3, 5, it shoots from kind of the origin, right? 3, 5. So if I want to say something like, if I go from 0 on the x-axis and I go 5 or 3 up. So if I go, let's change these values. So if I go 0 on the x-axis and 3 up, so 3 units up on the y-axis. And if I go 4 units across, as an example, and 0 on the y-axis, then this becomes a magic triangle, and we should get a distance of 5, 3, 4, 5 triangle. Let's see if that makes any sense, right? 3, 4, 5 triangle. So if I did it right, and if we did, we should get a distance of 5, right? 3, 4, 5 triangle. That's one of the magic triangles that we can get. Now notice that the dot product is 0. How is the dot product 0? Well, because we have a right angle, and what dot product does is if the dot product is 0, then that's another really cool property of the dot product. It says that our vectors are at right angles to each other. So we know here, this is a test that we've passed in some ways. So we know that these two vectors are at right angles. So there's like 90 degrees between the two. 3, 4, 5. And whenever we do a Pythagorean test, this is a good thing as well. Yeah, so console Writeline. Some people are saying in the chat we can go CW and tab, and that's a great way of doing it because it saves us some time. Okay, it's just like prop when I was typing the word prop, and then tab inside of a class. It makes sense, but console Writeline is something we want to know how to use. All right, so questions around static methods. We just give you some examples here, but 2 static methods of classes, and we need to know how to use static methods. You may have already covered this in from some sense. But what we want to try and do here is I want to go over it with you again because there's always been some confusion as to why do we need static methods? Why are they useful? Do we need operator overloading? Why is it useful? There's a lot of usefulness for operator overloading, and I wanted to show you that here. It's part of polymorphism, so that's why I wanted to show it to you. Okay. One more thing here. So we've got our vector 2D, and what we talked about is we have a game object and it has certain things. I want to make some properties from my game object. Right now, all we have is a transform. Well, we can say that maybe all game objects has some kind of durability or health value, right? All game objects has a health value. So if we did that, we could, these are private instance members. We can make that happen right in here, and we can say that we'll call this a private string, which is m_health. So we're making it up. We're changing. Here's where we're changing the superclass of both the enemy, the boss, and the player, right? So I'm affecting all those 3 classes by changing this one thing right here. Why? Because player, enemy, and boss enemy, they all derive from or are child classes of the game object superclass. So if I was to change anything now in the game object superclass, these 3 classes would be affected downstream. Remember we talked about this? This could be a bad side effect. In this case not, but it could be, right? So I'm adding a health, so private health value, and down in here, I'm going to define what that public property looks like. So public, and the value is going to be, again, we have to decide what that is. So right now it's a string. That doesn't make any sense. Let's turn that into, let's make it a float to make it more interesting. Because then we can have percentages of health a little bit easier, right? So we're going to say public float health, capital H. Usually we do a capital for properties, right? And then we're going to say get, remember? And we're going to have a set. You can also have, for your assignment, I noticed that there are, assignment 2, it asks for a single getter, no setter. That's a read-only type of property in many ways. So we're going to return the health value. So we're going to say m_health. If we do that, it's going to do one of these. I don't want that to happen, so I'm just going to put that back, right? And I'm also going to say that m_health is equal to value. So again, we're going to put these in place so that way we have a health. Now once we've done this, we need to initialize health. So inside our initialization function, right, we also should initialize all member variables. By default, the name variable is being initialized by the constructor function when we make a name. And I'm going to break the constructor function. I'm going to show you how to break this, because what I'm going to do is I'm going to also demand that whenever you make a game object, you also tell me what its health is. Float health. Okay, watch this break now. And I'm going to say that health is equal to health. So health being the property, health being the lowercase health being the parameter that we're taking into the game object. Okay? So this just broke player, enemy, and boss enemy. And the reason why it broke those things, if I was to run this thing, you're going to see is a problem. It's going to say, wah, something happened right now. And sometimes people will do this. They'll program and they'll be like, wait, how come I'm getting errors now? Oh man, because guess what? My player now needs something else for its base. It's not enough for me to ask for a name. It also needs a health value, whatever that health value is going to be, right? So of course, you can fix this by doing two things. I can put a health value in here, right? And I can do the same thing because now I broke enemy, and I also broke, boss enemy isn't broken, by the way, but it kind of breaks anyway because boss enemy derives from enemy. So because enemy's broken, then so is boss enemy. But enemy and player, definitely I could add in a health value. But the other thing to do instead is create a default value for the health. So I can say that, hey, float health, you can do it if you want, but by default, my health value is 100 points. And if I was to do this, 100 points, then you can see that now the player is okay, and so is the enemy, because now I have a default value for health. Make sense? So that's kind of how we do, that's how we can, I just showed you how breaking changes happen, right? I make a change to the superclass. Game object is the superclass of the player and the enemy. And as soon as I make a change like this where I demand that you must do something in the constructor, then the player and the enemy's base constructors have to call different base values. Or, if you notice the base, it also takes a health. And notice that when I hover over it, the health requirement is in square brackets. Square brackets for us means an optional value. It's optional, right? And if I was to use our documentation, so / for the constructor. Let me just go back up there and go to the constructor value. So this is the constructor value, and for the superclass. So if I do / it says parameter name is name and is health, and I can say that this constructor requires a name for the game object with an optional health value. And we can keep going. By default, the health, all game objects have a health value of 100.0f, 100.0 points. Okay, that's what default is. And if now that I've done that little comment, you can see that if I go to the player, right, and if I hover over this, it's going to give me that. It's going to give me that this constructor requires a name for the game. Oh, game, that's bad. Let's go back to game. I meant game for game object. We'll say for the game object with an optional health value. I'll be able to type well one day. Okay, so now if I go back to player and if I hover over base, you can see that that's indeed what I get. I get that information right in here, which is really useful to people that are using your class. So that's why comments are good. Okay, so that's great. So I got a health value. So now when the enemy fires at the player, right? So here's the enemy, and the enemy is going to fire the bullet. And let's assume for a second that every time the enemy fires the bullet, that the player is impacted. The player is going to be hit automatically, okay? And the player is going to take some damage. So let's suppose that the damage that I do, right, from the bullet is 20 points. Every time the enemy fires the bullet, the player takes 20 points of damage, all right? So here's a question for you guys now. How can I do that? I fire the bullet, right, as an example, and if it hits, right, as an example, right now I return void, but I want to return a damage value, right? So what I can do is I can, instead of firing the bullet and returning void, I want to take damage now. I want to take some kind of damage in terms of float. So I want to return a number. I'm going to say return. And the number that I'm going to return is 20.0f. That's the damage that I do with a regular bullet, right? And now I've broken things again, right? I've broken this yet again, right? Why? If I go to my boss enemy, you can see that now I've broken my override, right? Because why? Boss enemy, right? Boss enemy depends on or derives from enemy. And I'm overriding a function, but the function signature when I override must be the same. I can't override a function to make it void now, where before it was a float, right? So I got to change this to float. This would fix it. And when I fire my bullet, because I'm firing a fat bullet, let's say, for example, here's the real override. I want to return double the points, let's say. So I want to return 40.0f. So I actually do twice the number of damage when I hit from this kind of bullet. Okay. So why am I doing this, guys? I'm doing this because I want to show you what happens when you make breaking changes with inheritance. Inheritance is great, but what ends up happening is like we talked about before. So I'm going to bring up that little chart of ours again. So here's my little whiteboard. Right. So remember what we talked about. We said that if we have a superclass right here, so this is the superclass, right? Or we'll call this the base class, just to make sure that we're using the right terminology. Here's our base class. And then all child classes derive properties and methods from the base class, right? So they actually inherit. That's why it's called inheritance. And I'm going to make the one child class, we'll make it bigger. Remember, because one of the features of the base class is that the child classes are actually bigger. So let's make this child class over here a bit bigger. I'm going to actually draw it bigger too, right? And we can make this, kind of symbol. Typically what we do is we use an arrow that points up towards the base class. It's a bad arrow, excuse me. But this would be the child class, or we can also call it the derived class. The derived class is here, and the derived class inherits all the stuff that comes from the base class. But if I change something in the base class and the derived class has done something like override a method, well, guess what? Now we have a breaking change, which is what I was showing you before. Okay, so that's what happens. I pass things down, but now I change something up here after I've passed things down over here, and the derived class is expecting the interface for the base class to be the same, but actually changed. And so the method is changed, doesn't work anymore the same way, and it doesn't compute for the derived class. It breaks. All right, so be careful about this. This is one of the challenges of object-oriented programming. Okay. All right, so that is we do some damage. As an example, we know how much damage we do. And let's suppose also that the player has shield value. So that's something different that GameObject doesn't have. GameObject doesn't also have bullet firing, right? GameObject only has health. Player has health. Enemy has health. Boss enemy has health, right? Because so does our GameObject, right? And now that we've done that, we know that our one thing that we know for sure is that our GameObject not only can return our name, right, but also should return our health. So output string should change. I'm changing it on the GameObject because all objects have health, right? So I can do that. I know for sure all objects have health. So I can say health for this GameObject is equal to health, right? And I'm going to use a \n. So I'm modifying the toString value, okay? And this is okay, right? Because what I'm doing actually is I'm just adding something else to it. So if I was to run my code now, you can see nothing bad has happened. All that's happened is that I've slipped health in there as well. So player health is 100, right? I moved it to a different position. That's what I'm doing, moving my player, right? Moving it up to 120, right? I've done some calculations about two vectors. That's all I'm doing here, right? And now I want to do damage. So first of all, let's go back to my program. And before we do damage, we know we've done some dot calculations and distance calculations. So I'm going to add that into the GitHub repo. So I'm going to go here, home. I'm going to go to changes, right? And I'm going to say that we could have done other commits, by the way. I could have done a commit for health. I could have done a commit for the other things we tested. But I'm not going to do that. Let's assume that we made more than one commit. For you guys, when you make these feature changes, the assumption is that you make a commit for each feature or breaking change for sure that you make. Okay, so let's do that. Let's say that added dot and distance methods, static methods to vector2d. Please be careful. Don't go too long here because it'll complain. It'll say it's too long. The commit message should be fairly short. Commit all, and then home, sync, and push. And that's what pushes it up to GitHub. All right, cool. So we've made that change, but now I don't care about this stuff. This is just a test that I did here, so I don't care about this anymore. I can get rid of it. And I don't care about this anymore. These are just two random vectors. I want to go back to that other thing. I want to fire a bullet at the player, and let's assume again it automatically hits the player. Automatically hits. I'm not even going to change the player speed. The player is 100. I know that I can do operator overloading now and move the player according to its acceleration value, right? Which we haven't defined yet. But I want to make this enemy fire at the player. So I can say that enemy, we'll call this the red enemy, is equal to a new enemy, and we need to put a name to it. We'll call it the red enemy, right? We make a new enemy. We assign a transform value because, you know, we don't want the default 0, 0. And let's suppose the vector that we're going to assign is something like, I don't know, he's at 200 and 200. So some distance away, right? So this is the distance between the player and the enemy, right? So player and the enemy. I made player instead of enemy. And I want to say, I want to do a console log, console writeline. Oh, so we should use the CW again. Console writeline, and then enemy lowercase. So red enemy dot toString. So I want to get to know where the enemy is. Okay, so this is the enemy. So this essentially, I'm getting these fancy marks, and it says I'm using an enemy initializer, just like I'm doing it here, right? Here I'm actually initializing. It says that use object initializer. All right. So if I go here and go to here, it tells me, hey, use it. And if I was to show you what an object initializer looks like, it looks like this. So I can use initializer syntax instead, where I can use my enemy in curly braces. Now you guys should know this syntax as well, but I'm not going to go there because sometimes what this does is it creates some confusion. So I'm just going to make it this way so you can see it in 2 lines. But object initialization is perfectly fine and actually in many ways preferred. So here's my player. I raise my shields, right, as an example, and then I'm going to fire. My red enemy is going to fire at the player automatically. But first, let's get the distance. I'm going to say, you know, again, we can use the float, call it distance. And we'll use our new vector2 object. We'll say that vector2d, right? And I'm going to pass in the player.transform.position. And I also want to pass in the enemy, red enemy, transform.position. And now I have a distance. So I can say, so why am I getting this? It says non-invocable vector2 cannot be used like a method. Well, vector2 dot distance is what I forgot, right? I have to invoke the method, right? So that's something that I want to do, right? So then what I can do is I can do a console writeline, and I can say that the distance between the player and the red enemy is, and then some kind of distance, right? Whatever the distance is. Okay, so I want to calculate the distance between the player and the enemy. This is actually a good example of how this is working. Let's try this out first. So we can see here that I've got my red enemy player. My red enemy is 200, 200. And then the distance between the player and the red enemy is 141 units, right? Okay. And then what I want to do is I want to fire. So I'm going to say that the red enemy, right? I want to fire bullet. But when I fire bullet, I actually get a value back. Fire bullet returns a value, right? So we're going to say that player damage is equal to this. I'd like to do that, but what might be better is if I remove from my player a number of health. So I can simply do it like that. I can say that player.health, right? And minus equal to this red enemy fire bullet, right? When an enemy fires bullet, it's going to return some kind of value, and I'm going to remove it from the health value. And then of course, I want to do the same thing. I want to write the player to the screen again to see what the result is of his health. So every time that the enemy hits, now this is assuming that there's no shield. So even though I raise shields, I'm going to take direct hit. My shields aren't going to make a difference, all right? In this case. Think about a shield like some kind of armor, right? So let's run it, and when we get this, we can see that the player indeed has lost 80 points, or 20 points from his health. It went from 100 to 80. His position's the same, okay? So now we're going to say, well, the player's going to take some health damage, right? But when the player takes damage from health, right, if the shields are raised, I'm going to subtract. The shields can protect the player by 10 points every time they hit. Okay, so if the shields are raised, how do I do this? So in the player, right, we can say that right now we can raise shields, right? Raise shields, and when we do that, we don't really tell the player that the shields are raised. So we can say that we can have a Boolean. So we're going to say private bool. Right? And we can call it something interesting, M underscore shields raised, right? Right? Private bool M underscore shields raised. So why am I getting a variable? It says the namespace contain members such as fields or methods, right? Well, why? Because I'm trying to put it way out here, and this is interesting. I messed up. Again, this is good. No one told me about this. I put the constructor over here, but actually it should be here. Just the way I wrote this last time was really messed up. So this actually should be, I didn't even notice it till now, here. Wow, that's bad. Anyways, so yeah, so my private bool, my shields are raised. And what I want is I want to have a public property for this. I'm going to say prop and type bool, and I'll call this are shields raised, or is, shield raised, something like that. We'll just call it shields raised. Shields. I'm probably spelling shields wrong. Shields raised, right? So shields raised, and it says getter setter. I don't want to have a getter setter. Instead, I want to make my own custom getter setter. So again, just like we did before, we're going to say something like this, where we can use this keyword. We can just use M underscore shields raised is equal to true. Sorry. Return this. Okay. That'll be okay. And then when we want to set the value of that. So we're going to say something like shields raised, right? And how would we do that? So I'm going to say that M underscore shields raised is equal to value. Okay, so what my scope is, what I want to do is when I take damage, instead of doing a direct hit on my health, right, as an example, I want to check to see if the shield is raised, and if it is, I want to take damage. So I want to make a public method for this called take damage, all right? Because I don't have access directly to the health value, right? Notice that in my health for a game object, right, I have, it's a property here. So here's my property, my health property, right? And right now, my health property has, I can return health, and it has health or whatever, but that's what this thing does. And let's suppose I want it to go to player, because this is a public value, right? I mean, I still don't have access to doing anything to this way. So what I'm left with is there's two options, and I want you to tell me what the best thing to do is, guys. All right. One option is I can, with my player, I can make a new method, take damage, right? And that's another method that I have to take. But wouldn't it be better if I could override the property? Right? So in order for me to do that, I'm going to make a breaking change again, where in the health value, I can call this virtual. So I can actually virtualize the property as well, not just the methods, right? Virtual float, right? Now, does it break enemy? No. If I don't it's an optional thing. I may override if I have the option to override, right, in this case. Whereas in the player, I want to override this thing. So I want to override. So I want to go back and I want to go. So just like we did with the toString method, so how it would look, if you look at down here where we say public override, right? If I start typing override, right, it doesn't really do much. Override toString, but then look at this. It says override health. This is really cool. So if I double click on that, it says public override health. I want to override the way that health works. And now we might get into some trouble. Let's see how if we get into some trouble here. I want to override my health. I want to, when I get health, right, I want to return health. Then I'm going to just do the same thing. In this case, I'm going to say just return m underscore health. Oh man, I'm having a problem, right? I want to override my health value, but man, I can't do it. Why? And this is exactly what I was talking about before. Remember we talked about this? Cannot access private field m underscore health here. Why? Because my game object superclass has made the health value private, right? I can't do it. Even though I can override the health, I can't do anything with the health field. And this is where, remember that protected keyword comes into place to solve a problem. So I can make this protected instead of private. And if I was to do this, that means any class that derives from GameObject can modify or can directly access my health field. Now this is dangerous because I'm directly accessing. Some user might decide to say m underscore health is equal to, right? And that's why it's discouraged. But in the way I'm using it, I'm going to say that I'm going to return m underscore health, and I want to set health. When I set health, I can check to see if I have shields or not. And I can say if, right, shields raised, right, if it's true, then I'm going to remove a value from health. I can say that I want to return m underscore, I want to set m underscore health. M underscore health, right, is equal to the damage I'm going to take, right, whatever the value is, but I'm going to subtract it, minus the shield value. When we're going to say the shield value is 10. We can do that, right? So if it's true. Otherwise, if it's not true, I'm just going to return, and I'm going to say that, m underscore health is equal to value. Now notice that I didn't use an else, because what's happening is it's either if this one or this one, right? But this one, what it would do is it would override. So here I need an else because I'm not returning. So I'm going to say else. Okay, and if you think about this statement, right, actually it can be written better than this. This is a very poor way of writing this statement. The way I could write it instead, I'm just going to comment this one out, right? So let's just comment it out. The other way to write this would be in another format. So I'm going to say that m underscore health is equal to, in brackets, shields raised, right? If it's true, I'm going to say that it's going to be the value minus 10.0f. If it's false, I'm going to say that this is just equal to value. This is a better way of writing it. Okay? So can anyone tell me what this form is called? It's exactly equal to this for the most part. What is this called? Thank you, Ternary Operator. That's the way to go. Thank you, George. Kudos goes to George. George, if I can give you a prize, you get the prize today. All right? Thank you, George. All right. So yeah, it's a ternary operator. So use a ternary operator instead. Right? That's the better way to do it because it's a one-liner. It doesn't take up like all these lines. Right? So this is pretty cool, right? I can say, hey, and it's a value, but you know what? It's cool, but this is 10. Shield value is 10. And so if shields are raised, I haven't really said when I raise shields. So when I'm doing raising shields, I have to say that shields raised is equal to true. And you know what? Since I have a raise shields function, I should probably say that I can lower shields. So maybe I can say lower shields. Right? And when I lower shields, I can say lowering shields. And shields raised is equal to false. Right? So this kind of does that. One thing also that I have is I have no shield value. Right? So I could assign a shield value by default, some kind of shield value in here. So it's not hard coded. For example, I'm saying 10, right? So I could do that. I could say something like my private, it'll be a float type. We're going to say m underscore shield value. Call it shield level. That's better. Shield level, right? And we'll do a property for this as well. So we'll say prop. So we'll say it's a float shield level, right? And again, just like before, we'll do a get set. There it is. Okay. And in the getter, we'll say that the shield level is, we're going to return m underscore shield level. Sorry for the formatting. And otherwise, m underscore shield level is equal to value. All right. And whatever that value is going to be, we can set the shield level this way. Set or get the shield level. Here's shield level, right? So instead of us assigning a value, we can say that it's just subtracting the shield level. Okay. Let's keep this in mind for a second. So I can say shield level, okay? So whatever the shield level. Right now we don't know what the shield level is, and it'd be great if we set the shield level at some point, and that should be done where? In the constructor function somewhere, right? And so what we can do is in the constructor function, we could call an initialize method, because I would probably do something like other initialization here. So private m underscore initialize, right? Which returns void, but does a lot of initialization for us, right? We can call it initialize. If you're playing with Unity, it's called start, but it doesn't matter. Let's just call this m underscore shield level starts off at 10, and this some 10 units, let's say, or whatever it's going to be, right? And we call the m underscore initialize here. All right, so when the player is constructed, we initialize the player's shield level to 10, okay, by default. Okay, and now what happens is when we do damage, if the shields are raised, we can subtract the shield level, right? Otherwise, we subtract nothing. We just return whatever the damage is, we subtract. Now, if we do this, right, if we go back to our program, this is still good, right? But guess what? Instead of us taking 20 points, because the shields are raised, we want to take only 10 points. So this is cool. And if I ran this now, instead of us going down to 80 points, we should be at 90 points. Let's see if that's true. Why? Because we raised shields. So notice that. Oh, sorry. This is interesting. All right, so we actually went even further down. So I did 20 points, right, firing the bullet, but notice that it says 70. I've taken 30. Why? It's the way I've written it. Let's go back to player. So let's see how this works. So I'm actually subtracting the value, right, from my shield, right? But I've written it in the way that I'm saying, hey, whatever the health is, as an example, if shields are raised, then I'm taking my value and I'm subtracting it from shield level, right? Take shield level away and assigning it to the health, whatever that value is. However, if the value is negative, right, which is something that's going to happen, negative, then what ends up happening, the way we've written it, is going to add additional 10 points. So we want to make this a plus. It's just the way we've written it. Because if it's possible for us to take damage, then we want to add the shield level back to the health. That's what we're doing, okay? As opposed to subtracting it from health, okay? So let's run that again. And we can see now that the player's health is 90. But you see, this is great, a one-liner to say that, you know, the shields are raised and the shields absorb some damage. So we can do that. We can say that if my shield is raised, so shield's raised, right? And let's also assume that we can bring down the shields by them taking enough damage or something. But if my shield is raised, then what I can say instead is that we do a console write line that says something like players' shields absorbed some damage, right? Actually, we'll say shield level damage. Shield level damage. Notice how my code hinting automatically put the $sign in place because it knew what I wanted. So here in the setter, see, the setter is actually really cool because as I set things, I can do more than one thing. It's a method, right? Excuse me, as opposed to directly accessing the health value. All right, so let's try this again. Let's run it and let's see what we get. So we should see something of a message. We say the distance between player and the red enemy is 141 units, firing bullet. Player's shields absorb 10 damage, and then we can see that total damage is the damage that was done was 10. So let's do that again. So player's shields absorb 10 damage, right? And then total damage that was done is whatever the value is, as an example. So if the value is 20, as an example, and then I want to take the health damage from the value, and I want to add the shield level, and that's my new health, right? So I could say that, if I get hit, if it's set, I've taken X number of damage. If the setter is whatever, and I can make a if statement for this. I'm not going to do that here. I could also change this back instead of it using the ternary operator, because I'm also checking to see if the shields are raised here. It's almost to the point now where there's no gain from doing it this way, right? If I have more than one thing I'm doing. Okay, so I could do an else in here now. And instead of doing it this way, I could do the same thing. I could say that m_health is equal to value plus shield level, right? I'm doing that there. Else m_health is equal to just value. So I just took damage, whatever the damage is, right? And usually what we want to say is we can only take damage, and we can also check to see if my value is greater than the current health or less than the current health, right? So we can do that. We can say like damage, if my value, that whatever the value is, if it's going to bring my health down below what my current health is, then I can check to see what that is, and I can return a message. So let's go back to that, and let's get rid of this. We don't need this anymore. All right, because I'm kind of doing that in one step because I have other messages in here that I want to have in here, right? The other thing is that when the enemy fires the bullet, right? We don't know who's firing the bullet, and I could say that the name is firing the bullet. So I can say name, right, is firing the bullet. Notice it didn't do it that time. So whatever the name is firing the bullet. Red enemy firing bullet, right? And I could, once I've done this, I want to override this so that the boss monster, right? So name also is available to this. Name is firing the bullet. Okay, so that's how that works. Name is firing the bullet. And so we've done this test. So we've done the test here. So if I run it, you can see now it says a couple things. It says, hey, my red enemy is firing the bullet. Player's shields absorb 10 damage. Now the player is he's 90 health, right? What if the boss monster is also there and also fires at the player? let's check this value to make sure we can check it. So we're going to do the same thing. We're going to say boss enemy, we're going to call this boss, right, is equal to a new boss enemy, right? We'll say that the boss enemies, the boss's position is equal to, oh, this is interesting. I can use vector2, vector2d does 0. He's at the origin. Okay, I can do that. I can say the position's at the origin. He's at 0, 0. I could have also not done anything because by default he's at the origin. And then I can do a console write line where I said that the boss.toString is what I want to see. So there's the boss, right? And I also want to do the distance between the boss and the player. So I can also do that calculation. I'll say boss distance, right? Actually, it should be written in, if it's a method, it should be boss distance like this in here. So distance between the player and the boss, we'll say boss is right, boss transform position, boss distance, there we go. And now the boss is going to fire a bullet. So we're going to say boss dot fire bullet, okay? And now once the boss fires the bullet, right, we want to remove that from the player's health. So player health, let's say it automatically hits again, so there's no dodging. It's minus equal to the boss fire bullet, whatever the firing is, and we want to output the player's current status again. Okay, player toString. And let's write this out. So you can see now that player started at 100, right? He's raising shields immediately when he saw the enemy and the boss enemy. The boss enemy starts at 100, right? They fired at the player. The player's health is now 90. The boss is coming to play. He's at 0, 0 position, right? The distance between the player and the boss is also 141 units. Does that make sense? No, it does not. Why? Because we didn't change the boss distance transform. Boss transformed that position. Player transformed that position. Is that possible? 0, 0. And the player is at 100, 100. Yeah, actually. 200, 200, of course. Okay, yeah, so it's possible. Let's make these numbers slightly different. So 225. Just to make sure that we have our calculations correct. All right, now let's try it. 160, 141, good. And then the boss is firing a fat bullet. The player's shields absorb 10 damage. Now it went from 90. Normally the the fat bullet does 10 damage or 40 damage, right? But it absorbed 10, so it only takes 30, so it goes down to 60 points. Okay? Whew. Now you're going to say, why all this crazy stuff? Why are we testing it all this way? Because, again, this is more complex, right? This is more complex, and it gives you a sense of, we covered polymorphism in different ways. Today we covered overloading operators. We covered overloading methods, right? Static methods, okay? Overloading properties, which is really cool. It's part of, as an example, the whole polymorphism thing. So we've covered a lot of polymorphism, and I've kind of want to stop there for today. It's kind of we're at the end. I'm going to stick online now for the next 10 minutes for people who can. If you have any questions, I can kind of open it up to questions, whatever kind of questions you want. So I'm going to stop recording now, and then I'll wait for questions afterwards. Okay? And by the way, before we do that, let me go to my Team Explorer because we made all these changes, and I'm going to go to Home. I'm going to go to Changes as an example, and I did a couple things here. So we'll say, really, what change did we make? If you think about what we did, we modified the player at all. We overrode the health property of the player to allow for us to take damage, and we added the shield level and the ability for us to lower shields too. Okay, that's what we did. So When I go to Team Explorer, it's a lot. I probably could have made multiple commits here again, but we're just going to say added, well, overloaded player health property. Okay, that's what we did. So I'm going to commit all, home, sync, and push. And that should give you more practice by watching this to see how it works. Okay, again, based on small incremental changes to our program, and it's getting bigger and bigger and more complex. And I like this because it allows you guys to think a little bit harder as opposed to automatically calculate what the effect is going to be. Okay. All right, so I'm going to stop recording right now, and then when we come back next week, again, this week I haven't given you any kind of lab. I'm not going to do that this week. I know you guys are working on your assignment. I haven't given you a lab or a quiz. I'm going to wait. It's okay. We can always add labs and quizzes later in our semester, extra ones or even bigger ones that might make will end up being the same value. So don't worry about it. I want you to get comfortable with coding with me, coding with Tom here. And in order for us to do this, I want you to see the way I'm thinking first before we get into the some of the labs and quizzes that I'm going to hit you with. Okay. In the meantime, try to do this by yourself. Try and modify the player. So maybe the player is going to be able to, the shields can take damage. Every time the shields get hit, 10% of the shields degrade. So instead of the shields staying at 10 every single time, they might go, when they get hit a couple times, they'll go to 9, and then 8, and then 7, and then 6. And then eventually, when the shields are 0, you lower shields. No shields. Okay? All right, so you can try those kind of little changes for yourself. Hopefully you understand what I'm talking about. All right, let's end the stream now, and I'll see you next week.